Hello everyone. Today we have a circuit here to study. It's one of the boot sequence in MediaTek IC MT6357 CRV. Okay, we have two type of this kind of IC, MTK6357 CRV. We also have MT6357 MRV. Okay, they are the same IC, but there is a slight difference, okay, in the software configurations and also in the LDO sections. Okay, so there's a slight difference between this CRV and that MRV. One will have 28 LDOs, while the other one will have 29 LDOs. So there's a slight difference. So today we are going to discuss this MT6357 CRV. The boot sequence, okay, the boot sequence. When I mean by boot sequence, I mean the way the phone boots up, the process of booting up. Okay, you know, there are lines that must turn on first before the phone boots up. So it's called the boot sequence. But today we are going to discuss external buck converter. Okay, you normally hear people say external buck converter in mobile phone repairing. So today we are going to look at that circuit. Okay, so now I've made a diagram here. This is our charging IC, this is our power IC, then this is our CPU, and this is our external buck converter. Okay, you can call it second power IC, but it's not really a power IC. It's a buck converter, external one. Okay, I will tell you why they put this external buck converter. And then we also have LDO circuit here. This is an LDO IC that generates VA 1-2, okay, and send it to our CPU. So now I'm going to mix this block diagram with schematics so that you will understand. We have your charging IC. You know how charging IC works, okay? This is our VPH line. But in this type of charging IC, in this type of circuit, this MediaTek IC, we don't call it VPH, we call it VCs. So I put this VPH so that you will understand this line, because most of us are familiar with the name VPH. So in this MediaTek, we call it VCs, but in Qualcomm, we call it VPH. So this line is VCs according to this MediaTek IC. So after our charging IC might have worked, okay, you see a line, VCs line, that carries coil. This is 1 microhenry coil. Okay, it has 3.7 to 4.2 volts in our charging IC. So this coil will enter our power IC, and this line, this VCs line, it goes to different sections. Okay, if it goes to different sections, number one, it enters our power IC, it goes to network, it goes to audio, it goes to your Wi-Fi, Bluetooth, it goes to different circuit, your display, your backlight. So this VCs line goes to different places, but today we are going to discuss the one that goes to power IC. So this it will enter power IC, okay, and before it enters power IC, it will have lines. Okay, it has, let's say, 5 lines that enters power IC. This VPH will come and separate itself into 5, okay, into 5 lines, and then it will enter our power IC. And there are capacitors connected to each of the lines, and those capacitors you surround the power IC. Okay, those capacitors will surround the power IC. So now let me show you in schematic the capacitors I'm talking about. Okay, I've opened our schematics here on Hardware Solution to show us the capacitors that we are talking about. So this is the first capacitor, and then this is the second capacitor. Then we have here our third capacitor, and then the fourth capacitor and the fifth capacitor. So now we have, the reason why we have 5 capacitors on this VCs line is because we have 5 buck coils on these lines. So if the coils are 9, we will also have 9 capacitors, and these capacitors come from our charging IC VCs. Okay, so after that, the VCs line is done with its work. Okay, it's done with its work. Now the power IC will then take that line, that voltage that enters into the power IC, and then boot up. It will regulate the voltage, and then it will create coils. you see all these inductors. We have 5 inductors in this type of IC. There are 5 inductors. Okay, so now these inductors will step down the voltage. This 3.7 voltage, it will step it down, and then it will produce more ampere. It will generate more current so that it can power up the CPU and other sections, but it will step down the voltage. That's the work of buck coils. So now, but there is an external IC here that is installed. So in this first buck coil, we have here modem. Okay, this is our modem line. Then the second coil will be V core, and then the third coil will be voltage for processor, V pro. Then the fourth coil will be VPA. This is voltage for power amplifier, and I will show you how these lines connect. Okay, now the fifth coil is V6. Now the first coil is V modem. This coil has its special functions. Now this coil goes to our CPU. You see the arrows that I've made. It enters our CPU. Now it will carry, let's say these lines will carry 0.6 to 0.8 volts. Okay, now this modem will enter our CPU. Then the V core will also enter our CPU. The V pro, that is voltage for processor, it will enter our CPU. But when it comes to this VPA, it's not entering our CPU. I've indicated that this line does not enter our CPU. I've mistakenly connected this line to CPU section, but it doesn't go to CPU. So this line will end here. This line will go to your network section. This is voltage for power amplifier. So this line goes to our power amplifier in our network section. Okay, now there's the fifth coil that is called VS1. Now this coil is called VS1, but it is the higher LDO. In Qualcomm, you see the higher LDO, HLDO, that is high LDO. Then you also have lower LDO in Qualcomm, but in this other MediaTek, you will see instead of higher LDO, you see here VS1. Now there's what we call VS1 and VS2. This is VS1. This coil generates VS1 line, and then this external buck converter will generate VS2. Okay, so this is our higher LDOs. Then this one will create our lower LDOs. Now the work of LDOs, without this coil generating, our LDO section will not power up. Okay, so this coil create our VS1, which is our higher LDO, and the voltage there will be 2.05 volts. 2.05 volts is responsible for this line. So this line will generate 2.05 volts. VS1, that's our higher LDO. Now this line is the one to power up our lower LDOs. So now this line will go back in our Qualcomm. This line will go back to our power IC and create our lower LDOs. But in this MediaTek, there's an external buck converter here. Now, the reason why this company, MediaTek, did not make this power IC to create both our higher LDO and lower LDO is that maybe this IC is weak. So now, they say instead of us giving this line again back into our power IC, let's make an external IC that will generate our lower LDO. That is our VS2. So now they create this coil. So now, according to the boot sequence, if you don't know how boot sequence work, join our online training course. There we will show you how boot sequence work, both in MediaTek, Qualcomm, SPD, and the rest of the IC. Okay, so now this is our VS1. Now this line will come out 2.05. It does not go into our CPU. Now it comes to this external buck converter. Now I'm going to show you this external buck converter so that you will know where it is located. So this is our external buck converter. It is located near our power IC, and this model have 6 pins. Okay, there's some models that have 8 pins. So this is the coil beside it. So this is our external buck converter. So now this is our external buck converter. This line will enter this pin, this enable pin 1. Now this external buck converter, I've made an 8-pin external buck converter here, but in some models you will see the 6-pin is still correct, because some of these pins there are NCs. Okay, some of these pins are NC, like pin number 4, pin number 5. There are NC line that is not connected. So there are some models that use this 6357 CRV that you will get this, that you will get 8-pin external buck converter. There are some that you will get 6-pin external buck converter. It's still the same. Okay, these two lines are not connected. Now we will have our enable line. It will enter this external buck converter. Now the purpose of this external buck converter is to step down this voltage, because this is an higher voltage, 2.05 volts, and this external buck converter will convert it. It will step down the voltage. Okay, and then the voltage will step down from 2.05 volt to 1.4 volts. Okay, now let me explain something to you. When this enable line enters this external buck converter, now there is another pin that takes in V6 3.7, that is voltage from our charging IC. There's a pin that takes in this V6 3.7 volt. This volt will boost up this, will enable this external buck converter. It will boost up this external buck converter. Meanwhile, this one will enable it. Okay, so now when it enters, the external buck converter will regulate the voltage and step it down to 1.4 volts, so that it can generate higher LDOs. Now there is a line that is called feedback. This line is very, very important. It has a divided circuit here, single divided circuit. Now there is a buck coil beside this external buck converter. So this coil is our VS2 coil. So now, instead of you seeing this coil here, the company bring this coil to this side, because they provide an external buck converter that will create this coil. Now this power IC cannot generate this coil, because for one reason or the other it's weak. Let me just use the word, it's weak. So it cannot generate this external buck converter. If it cannot generate this coil, this line, this VS2, you understand? So now the company decide to create an external IC that will generate this VS2, since this one is not capable. You know, that's the main purpose of us, of you seeing different IC, like 2 power IC, 3 power ICs in one phone. Why? Because the features in that phone are many. So one single power IC cannot handle it. So they decide to add extra power IC. You see the 2 power ICs, sometimes 5 power ICs in one phone. Okay, because one power IC cannot do the function, cannot power up the phone, because the phone have a lot of features, all these advanced games, a lot of things. The CPU needs more current, more ampere to function. So the one power IC cannot generate that kind of ampere. So they decide to add extra power ICs. So, and you have to upgrade your knowledge, because one part, the sequence of booting for one power IC is not the same with 2 power IC. So now that's why you need knowledge. Join our online training course, you will learn a lot. Okay, so now this VS2 has been generated. Now this VS2 carries 1.4 volts. This external buck converter convert that voltage, is step it down to 1.4 volts. Now it will enter, comes back and goes to our power IC. Okay, this is our power IC. It will go to our power IC and then enables the lower LDO section. This is our higher LDO. It is being formed. Now this our higher LDO is the one to turn on the lower LDO circuit. So now this is an external buck converter here that will generate that line for lower LDO. So now the line has been generated, and the line is VS2 1.4 volts. So this line will go back to our power IC, and then it will turn on our lower LDO section. So now this line does not only goes to our power IC, there's another line that goes to this IC, because this line is to go to our CPU, but our CPU cannot handle 1.4 volts. So they need another LDO that will step this 1.4 volt down, so that our CPU can take in 1.2 volts. That is the higher volt that this CPU can take in, 1.2 volts for this particular circuit. So now they create another IC that will step this 1.4 volts to 1.2 volts, so that this VA112 line can enter our CPU. Now there is a divided circuit here after our coil. Now if this divided circuit is not working, is not enabled, maybe this resistor is faulty, or the resistor is not connected to ground, or the resistor is burned. If anything happens to any of these two resistors, maybe the value drop or increase, that means that this external buck converter will not generate this 1.4. okay, so even though all these lines are creating voltage, but this line is not working, it means that this external buck converter will shut down. So now this line will takes this 1.4 volts, and then it will step it down, let's say to 0.6 volts. So now this 0.6 volts will come back to this external buck converter in our feedback pin, and then it will tell this external buck converter, okay, go on, okay, everything is okay. It acts as a security. You know, for example, if a governor wants to travel, they will send the securities ahead of him. So the security will monitor every road. They will check every place that everything is okay. Then they will send signal to the governor, okay, come, or to the president, okay, come, everywhere is clear. So that is the work of this line. When it comes out with that voltage, it will surround, it will check that everything is okay. Then it will come back and tell this external buck converter, okay, you can go on. So now this external buck converter will wait for the signal that this line, this feedback line, will give him. So without this signal, this external buck will stop its work. Okay, so this signal will come and tell the external buck converter, okay, my brother, go on. Everywhere is clear. No issue at all. Go on. Now this external buck converter will then create this line, 1.4 volts. And then there's another IC here. Now let me show you this external buck converter. Let me show you this divided circuit on schematics. Okay, so this is our external buck converter IC. We have VS1 PMU. This line enables line. So this line comes from our power IC. So it enters this IC, and here we have our coil. This is our inductor PL2305. Okay, so this inductor is on our output side, on our output line. So this inductor, you see 1 volt to 1.3 volts on both sides of the inductor. So here we have a capacitor, but the capacitor is NC, not connected. So on this line, this is the resistor, the divided circuit I said I will show you. This is R1 and R2, but in this case it is NC. In this type of model, it is not connected. Okay, there are a lot of models that you will see as it is connected. So now this line goes to it has a capacitor here. It's still NC. Okay, this line goes to our VS2 PMU. So this PMU will go to our LDO circuit. Let's copy and check where it's going to. So this is going to our LDO VA12 IC. This is an LDO IC that we are going to discuss. Okay, now this external buck converter will create this line. There's this IC. There's this LDO IC for V812. Okay, now this IC will step down this 1.4 volts to 1.2 volts and send it to our CPU. Now, even if this IC, this external buck converter is okay, it's working, and then this other one is not working, your phone will not turn on. It won't turn on. So now this IC, we have a boost line, V6 line, 3.7 volts. From this charging IC, it comes and boosts up this circuit. So we have our input voltage, which is our 1.2 volts from our VS2. Notice that our VS2 has been generated. Okay, our lower LDO's line has been created. So now it comes back to our power IC. Now the lower LDO circuit section is being formed now, but this IC will not still turn on if this LDO for VA12 is not working, it's not entering our CPU. Now the CPU will send this voltage, this 1.2 voltage from this line. Or even if this one is okay and this one is not okay, your phone will not turn on. Sometimes the bulk voltages will be fluctuating. Okay, it will be fluctuating. Sometimes it will not even generate. Sometimes it will generate, but it's not going to turn on. So I don't care about the. I know that many people they really want to know how the DC supply readings works. They say if I have a phone is reading up to 100, it will go back, it will stop, all of those stuff. Don't really focus on DC reading. The purpose of DC reading is to give you a clue. It will give you an insight where to start working. Okay, it tells a lot, but don't depend on that. Know the sequence. When you know the sequence of how this IC boots up, my dear, you can figure out, you can trace the fault. For example, if you have 24 lines that need to turn on first, those 24 lines, the first line will turn on, the second line will turn on, the third line will turn on, just like that. Now if the seventh line is faulty or is having short or is not creating any voltage, now the rest of the line will not turn on, and then your power IC will not turn on, because all those lines need to enable, they need to turn on before your phone will boot up. So if any of that line is faulty, your phone will develop many faults, it will not even turn on. So it would show different readings. Maybe if the fifth line is 40, now it might give you a reading that let's say from 1 ampere, it will take you to 20, 21, then sometimes it will drop back. Now that is the fifth line working, it's not functioning. But if the fifth line is good, now you check other lines. Maybe one of the, let's say the 14th line is not functioning, it's not okay. Now the DC supply will give you a different reading. Like it will give you zero, let's say it will start from 0 ampere, it will increase to, let's say, 30 something, 40 something, sometimes then it will drop back, or it will come back to 20, it will go back to 30 something, come back to 20. So now it means that line is 40. So now you will not know the exact line. So all you have to do is to know that maybe the line is not turning on. So you start from the first line and then trace it one after the other until you locate that line that is having fault. Number one, that line might be having short. Number two, it might not have short. Maybe the voltage on that line might not create, or it might not generate. So this external buck converter is one of the lines, according to our boot sequence, is one of the lines that is 40. If this line is 40, the rest of the line after it will not work, and then your phone will not turn on. So the DC supply might give you a readings indicating that this line is 40. So it might change readings, so you don't have to focus on DC supply. Okay, so now let's go back down this LDO circuit. Let me show you this LDO IC on schematics. All right, so this is our external buck converter, and then the output is VS2PMU. This is the output. So when we click this output, it's going to take us to our LDO IC that will generate our VA12. So now this is our LDO VA12 IC. Okay, so now the first line is our VCs. Let's zoom in so that we can see clearly. Okay, so now the VS2PMU comes in and enter into this IC, but there's a capacitor that is connected. Okay, so this is our V in line from VS2PMU. So we have another line that is called VCs with 1K resistor. So if this resistor is open, or if this resistor is burnt or is faulty, your phone will not work. Okay, so you have to check this resistor also and measure the value and make sure that it gives you 1K. Okay, so there's another line that is called enable. This exists PEMIC enable 2, and it has a test point here. Okay, so if you check this, it's coming from our power IC. Okay, it has enable 1, enable 2. So let's check. This is our MT6357. This is our power IC. So this line comes from our power IC. So if this line is open, your phone will not also work. Make sure that you check the test points
to know if that line is working. So this other one is grounded. Okay, so now this line is connected to the divided circuit, and the voltage out is also connected to our divided circuit. So this is our resistor 1 and resistor 2. Okay, so they have value 24k and then 16k. So now if you want to know where this resistor is located, you have to copy this resistor, then go to your bitmap and then paste, and then it will lead you straight to where this resistor is located. So we have copied it. Let's copy it. We have copied it. Okay, so now let's go to our bitmap. I've already opened the bitmap. So now this is the bitmap. So we come to this search menu and then we paste it. Let's paste it. Then when we search it, it's going to take us direct to our resistor. That's our R1. So this is our resistor. Okay, this is the output side. Okay, so this is where this resistor is connected to. Okay, this IC. So this is our LDO VA12. So if any of this resistor is faulty, your phone will not work. Ensure that the divided circuit is working very well. Okay, so, and this VA12, if you copy and check, it will take you to our CPU, because this line is connected to our CPU. Okay, so let's copy it and see where it's taking us to. So see, we have clicked it takes us to our CPU section. So this line connects to different places, it goes to different IC. So that is where it is connected to.
So now this LDO will generate, we're taking this 3.7, sorry, this 3.7 volt from VCs, and it will also taking this 1.4 volt from our lower LDO VS2. So now it will enter, there are capacitors on this line, so you will test to see if the voltage has entered. Now if this IC is not creating this 1.2 volts, your phone will not turn on, because this 1.2 volt goes to our CPU. So now when this line creates this 1.2 volts, there is a feedback line also. There's a divided circuit here. This R1 is 24.3k, this one is 16.9k. So now this divided circuit will bring back feedback to this IC, just as this one is. Okay, there's a divided circuit here, so this one also have a divided circuit. If any of this is divided circuit, any of this resistor is faulty, your IC will not work. So now the IC will wait for this line to signal it to continue its work. So this line will come out and monitor that everything is okay, everywhere is good. Okay, it will come back to this IC and say, oh yeah, continue. So now this IC will send this 1.2 volt to this IC. If there is no 1.2 volt on this line, your CPU will not sense the voltage, and your power IC will not work, because CPU must send this voltage and give feedback to power IC. Oh yeah, continue, this line is okay. So now the sequence will move to another line. Okay, we move to another line of sequence. All right, so this is how this circuit works. If you don't understand, ask questions, and if you want deeper knowledge, join our online training. Okay, there we will show you a lot. You learn a lot. Okay, so now this is how this circuit works. If any line is faulty, your phone will not turn on. Okay, so this is where we end this video for today. On our next video, I will bring more tutorials to us so that we can be able to know how power circuits and the rest of the circuit works. Thank you for watching this video to the end. Remember to like this video. There are a lot of technicians that need to know these circuits, so share this video to them. Yes, let's be our brother's keeper. Share these videos to them. Like the video, comment, subscribe. See you in my next video.